Hi there. We're going to continue with the instruction set. Next in line is the software interrupt instruction, which we've already dealt in the labs. Okay, SWI. Okay, SWI, it causes a software interrupt exception, or nothing but an interrupt. Okay, which calls the operating system routines, OS routines. I think we've already studied that in operating system. Right, now the syntax here, you can see here SWI followed by a condition. Again, it's an optional. Okay, and followed by an SWI number. What is that? We will see that as the topic progresses. Okay, so what happens when an interrupt occurs, a software interrupt occurs? So this is the procedure here which is given here. So when an interrupt occurs, the current value of the PSR, that is actually stored onto the SPSR, that is the saved program status register. Now the SWI interrupt, it usually occurs, okay, we say that it occurs in the user mode. We have already studied 7 modes. Okay, so let's assume that SWI instruction is used in the user mode. Okay, so when the interrupt happens, now the mode will be changing to the supervisory mode. That is the reason we have given LR underscore SVC here and SPSR underscore SVC here, which means we are going to use the supervisory mode of the ARM. Okay, so here the current value of the PSR is getting stored to the SPSR. Now what about the CPSR then? The CPSRs, you can see that the mode is changed equal to supervisory SVC, and that particular control bit, I bit, which stands for the interrupt, nothing but the slower interrupt or the lower priority interrupt, is equal to 1. 1 means it is going to be disabled. Okay, it's going to be masked or disabled. Now the current PC value, actually PC will be holding the address of the next instruction after the SWI. Now what will happen is PC should be loaded with the vector address of the routine, the OS routine. That's why you can see here vector plus 8 is given. So if vector is equal to 0, it's 0 plus 8. Okay, it's going to go jump to that particular branch or jump to that particular location. Okay, now what is link register used? Link register is going to save the return address. What is going to be the return address? The address of the instruction following the SW. And following means just right after SW instruction. That will be held in link register. So this is the process what happens during the execution of SWI instruction. Okay, so I've already told this thing, which I'm just showing it to you in the slide here. Okay, you can just go through it for a minute. You can see here it sets the program counter to the offset x8, that is hexadecimal 8 in the vector table. And I already said that the processor mode will be changed to supervisory mode, and each SWO has an associated number, which I'm going to say that in the next slide. You can see an example here. Okay, now how is that SWI number got? Usually the SWI number is got by actually using an instruction called as BIC. Okay, you can see here in this particular slide that SWI number is nothing but the SWI instruction, whatever number is mentioned over there, and we are going to AND and NOT, nothing but we are going to use the BIC instruction. The equivalent instruction is BIC, bit clear. So nothing but knotting the value with this FFF, sorry, the FF, and all of them are 0. Okay, so nothing but 3 bit. So nothing but the first few bits, to be precise, the first 8 bits, are going to get masked, right? And not. So this will become FF will become 0 0, and rest of the bits will become FFF if we not it. And then when we AND it, we know that since these two digits are zeros, that is the first 8 bits are zeros, that is going to get masked, and then we are going to get the number. Okay, now let's return to the previous slide for an example here. Okay, assume that this is the instruction which is going to be executed. Okay, this is the instruction which is going to be executed, SWI, with this particular number. Okay, now before the execution, you can see that the CPSR value is NZCVQIFT underscore user, indicating that SW instruction is uh, executed in the user mode. Okay, the current value of PC, link register, everything else is given here. Okay, and R0. Okay, now R0 is equal to 0x12. How did that appear here? For that, we need to actually study something called as the ARM ATPC. Okay, the ARM APCS. Okay, it's nothing but the procedure, the ARM's procedure called subroutine. Okay, so we had actually seen that in one of the slides previously, which I hadn't said that clearly. Okay, so there are some what do you call, a protocol related to that system. So certain registers are allocated for argument, storing the arguments, etc. Okay, I'll come to that maybe in the doubt session. Okay, so you can see that here, after execution, the CPSR value, what happened to CPSR value? CPSR value underscore SVC. So this the mode has been changed. Similarly, I is capital now. Right now, you can see the change here. I has become capital letter. That is because it has become it's nothing but we have masked it or disabled it. Okay, as I had said, mentioned it earlier. And the SPSR value is nothing but this value from the CPSR. It's copied to SPSR. And the PC value, since vector is equal to 0, 0 plus 8 is there, so we get 0x0008. Link register will be having the address after this, that is nothing but 8004. Right, so I think this thing is clear here. Okay, and that's the end of it. It's just the end of this particular example.